Hi guys, welcome to section B. We're going to keep talking about volcanoes, okay? So these different volcanoes form different kind of shaped mountains there. That lava dome one, that number 4 one, we're not going to talk about very much. So I'm going to go ahead and keep that covered, okay? We've got a shield volcano. This is number 3 down here, which is a much lower, wider volcano. Okay. Usually, when you think of a volcano, you think of this nice cone shape, but these shield volcanoes are formed by very quiet, runny basaltic lava, and it just forms these broad, flatter mountains. Okay, which is known as a shield volcano. Cinder cone. That's kind of the stereotypical volcano that you think of. They're relatively steep. They are usually exploding with pyroclastic flow. Okay, so the solid stuff is usually coming out, but there can also be lava coming out. Okay, so at some point there was definitely lava because that builds up the structure of the mountain. But then if a big enough pyroclastic flow happens, it can actually blow off the top of this mountain here. Okay, so the nice steep-sided ones are called cinder cone volcanoes. And then finally, we've got these stratovolcanoes, also known as composite volcanoes. And these ones alternate between pyroclastic solid eruptions and then the liquid lava flows. Okay, so the layer of the lava will cool, and then the tephra from the pyroclastic flow will land on it and kind of settle down, and then more lava will flow, and so you get these layers upon layers. Okay, and you can see the stripes, you can see the layers here. They kind of indicate that in all of these volcanoes because it is a possibility. But the composite volcano very regularly does that. Okay. All right. This is Crater Lake I was telling you about in the last section. Okay. That is a huge caldera. So at some point that was probably a cinder cone volcano when it erupted, yeah, probably a cinder cone. And this huge eruption happened, and it took the whole top of the mountain off. And what you're kind of looking at is the remnants of what was probably a magma chamber. Okay. And that huge depression now is known as a caldera. That's Crater Lake right there in Oregon. Okay. So geologists talk about the different types of activity of a volcano. Okay. Obviously, an active volcano is one that is actually actively erupting, or that's showing a lot of signs that it's probably going to erupt pretty soon. And those signs could be a lot of little earthquakes in the area, those fumaroles where the gas is leaking out in different areas. And there's hot springs we're going to talk about in the next section. There's hot springs around these volcanoes. If the temperature of the hot spring is going up, or there's just different like materials being found, so geologists will look at the activity of the hot springs near the volcanoes to kind of get any clues that maybe an eruption is coming. Okay. We also get dormant volcanoes. These are kind of the sleeping volcanoes. They're not dead, but they're not very active either. They're kind of hibernating. Okay, so it's an inactive volcano, but it could erupt in the future. And then finally, we've got the extinct volcanoes. Those just show no signs of activity at all. And more than likely, it's eroded away. Like that Crater Lake has eroded away with the explosion. Part of the mountain is gone. If it's eroded away enough, you can kind of visualize the magma chamber and see that there's nothing there. There's nothing feeding it anymore. So you know it will not erupt again. Okay, but unless that's the case, a volcano is not truly extinct. Okay, so unless the magma chamber is visible and empty, it's hard to call a volcano truly extinct. Okay, because you never know. All right. We have different measures of explosivity. Okay, we talked about earthquakes and we talked about the Richter scale and the magnitude of the earthquake. Well, there's scales similar to that for the size of volcanoes. Okay, that is a pyroclastic flow right there, and it's emitting all that tephra, right? So we use the volcanic explosivity index, or the VEI, to describe the intensity of the volcano. Okay, it takes a bunch of things into account. It takes the amount of destruction that happened, the actual like cubic footage of the tephra. Okay, so all this stuff is going to settle here. Let me get my pen. There we go. All this stuff is going to settle. Okay, And there's going to be ash, in the region. There's going to be those cinders and all that stuff. So the amount of tephra is one of the factors that are taken into account to figure out this VEI rating, but also the height of the cloud. How high up that ash cloud goes is a determining factor. Okay. So in the book, actually, if you read on page 188, there's a big description of this big eruption called Mount Tambora. It was given a VEI of 7. And there was so much stuff that came out, so much tephra that came out. The next year on the planet was actually colder due to the ash that filled the atmosphere. The next year after this eruption was known as the year without a summer, because the ash blocked the sun so much. It filled the atmosphere and it blocked the sun so much, it actually had an impact on the weather. Which, side note, this is a really good series, kind of a apocalyptic kind of series, science fiction-y. This is the first one, Life as We Know It. There's actually 4 books. What happens is the moon gets knocked much closer to the Earth by an asteroid, and the gravity of the moon causes a ton of volcanic explosions, ton of volcanic eruptions, because the gravity's pulling on the magma more, creating more pressure. Okay. Well, so many eruptions happen that the atmosphere fills with ash and it blocks the sun out, and the plants stop growing because plants need sun to grow. And so it kind of spirals downward from there. So if you're interested, it doesn't scare you too much, I recommend this series of books. Okay, so Mount Tambora was a VEI of 7. I'm going to show you a couple more on the next page here. But I keep talking about these geologists. They're actually more specific than that. They're called volcanologists. Totally sounds like a Star Trek kind of thing, but a volcanologist is a scientist that studies volcanoes and helps rate them. Okay. All right. So the picture on the left there, those blue pictures, that is Mount St. Helens. That is an eruption that happened in 1980 in the state of Washington. I was just a kid. I was very young at the time, but I still remember the ash falling on us from the state of Washington. There was a lot of ash. When we get forest fires around here, sometimes you get ash falling. The ash from that pyroclastic flow actually traveled all the way down here to Southern California. So that's a before and after picture of the mountain. Okay, you can see all this part of the mountain is missing. It just blew out. So there's a lot of tephra from that explosion, but it only got a VEI rating of 5. Remember, Mount Tambora was 7. Okay. Well, I don't know if you know this or not, but Yellowstone National Park is on top of a very, very large volcano. In fact, it's called a supervolcano, and it hasn't erupted in a long, long, long time. But the volcanologists and geologists predict that when it did erupt last, it would have been about a VEI of 8, so even bigger than that Mount Tambora one. And this circle here, this is a depression that is the majority of the state of Wyoming. That's considered a caldera, so a depression from the previous explosion. Now, there's still plenty of volcanic activity there. We'll talk about like the hot springs and the geysers and stuff in the next section, but there's still a lot of geothermal activity because the magma is still there. So that is not considered an extinct volcano. Scary. That's all 2020 needs, right? All right. That's it for section B. Bye, guys.